Hey everyone, in today's video, we will be learning about octal numbers. And also we will be learning about hexadecimal numbers too. So this video will kind of build upon our knowledge on binary numbers. So if you haven't watched those videos, then please go back and review those. But without further ado, let's get started. So octal numbers are also called base 8. This is because they have 8 digits from 0 through 7. And you can convert from binary to octal in a very simple way. All you have to do is group together 3 bits and then convert each 3-bit into its corresponding octal number. Remember, a bit is a binary digit. Okay, and then after that, after you convert it, you simply just smush those digits together. Or yeah, smush those octal numbers together. You don't have to add or anything. So let's just go through an example. Say you want to convert this binary number into octal. So first, you group it into groups of 3. Starting from the right and going left. And so you get 110, 010, 001, and 001 are your groups of 3. And then convert using this table, or you can convert in your head, or on your own. But basically, convert these groups of 3 into octal numbers, which are basically just base 10 numbers that only go up to 7. Okay. Or for the first digits. Okay. So 110 is equal to 6, 010 is equal to 2, 001 is equal to 1, and 001 is equal to 1. And then you put the digits together, you get 1126. So this number in binary is 1126 in base 8. Okay. And say you wanted to convert from octal to binary. You want to go the opposite way, right? So if you wanted to convert 1126 into binary, you simply take each digit apart and then write each digit as 3 bits, and then combine the binary bits together to get a binary number. Pretty simple. So try these practice problems and pause the video to work on it, and I'll show the work if you finish or get stuck. Okay, now I'll show the work and show the answers for these. So this first one, right, you group it into groups of 3, starting from the right and going left. Then convert each group of 3 into an octal number. And then smush the digits together. Same thing for the next one, right? Groups of 3, convert each group of 3 into a octal digit, and then just smush the digits. Okay. Now, say you wanted to convert octal number to base 10. You can use expanded notation for this, just like binary numbers. So, for example, 1126 in octal is equal to 8 to the power of 3 times 1 plus 8 to the power of 2 times 1 plus 8 to the power of 1 times 2 plus 8 to the power of 0 times 6. And then you find out what 8 to the power of 3 is, which is 512. Find out what 8 to the power of 2 is, which is 64. And then you basically solve this equation to get 598 in base 10. Now we can also use a chart, just like we did in binary, right? So in binary, the bottom row of our chart was 1, 2, 4, 8, and we doubled it every time. But this time in base 8, we start with 1 again, but then we multiply by 8 every time. So we start with 1, then get 8, then 64. 64 times 8 is 512. And then you put the digits, the octal digits, with their corresponding values, or in the right box, basically. Then you multiply, right? So 1 times 512, 1 times 64, 2 times 8, and 6 plus 1. And you add it together, and you get 598. So those are 2 ways to do it. Okay, try these practice problems using either expanded notation or the graph method, and pause the video and resume it when you finish or get stuck. Okay, Now we'll continue. So these answers will be in expanded notation, but if you use the graph method, you should get the same answer, and it should look pretty similar. So 1216 in base 8 is 8 to the power of 3 times 1 plus 8 to the power of 2 times 2 plus 8 to the power of 1 times 1 plus 8 to the power of 0 times 6. Then if you do this equation out, you end up with 654. For the next one, answer would be 637. All right. Now, how about adding and subtracting octal numbers? Well, adding and subtracting octal numbers is the same thing as adding and subtracting binary and base 10 numbers. So, for example, if you were to do 645 plus 372 in octal, right? You simply do 5 plus 2, which is 7. I'll cross this out first. Okay. 5 plus 2 is equal to 7. 4 plus 7. Now remember, 7 is the maximum digit in octal. So what you want to do when you encounter 4 plus 7 is you say this, right? You're at 7. Now 7 plus 1 in octal is 1, 0. Now 7 plus 2 in octal is 1, 1. 7 plus 3 in octal is 1, 2, and 7 plus 4 in octal is 1, 3. So basically, every time you are at the maximum, you just add a digit and you count from there. Okay, now we have 1 plus 6 plus 3. 1 plus 6 is 7. 7 plus 1 is 1, 0. 7 plus 2 is, so 7. 7 plus 3 is 1, 0, 1, 1, 1, 2. So 1, 2. So the answer is 1, 2, 3, 7 in octal. Clear all drawings. Okay. Now how about subtraction? Same thing, right? 5 minus 2 is 3. 4 minus 7. Well, 4 is smaller than 7, right? So we borrow 1 from the 6. The 6 becomes a 5. So 4 becomes a 1, 4. And how many numbers, or how much does it take to get from 7 to 1, 4? It goes, so you have 7, then you have 1, 0, 1, 1, 1, 2, 1, 3, 1, 4. So it's 5. And don't be afraid to count on your fingers. I do this all the time. So yeah, an octal counting on your fingers makes things a lot easier. Okay. Now we have 5 minus 3, which we all know is 2. So we get 253. Okay, now try these practice problems. And then if you're not finished, pause the video, but I will explain it now. So 426 plus 372. You first add 6 plus 2, right? So you get 6 plus 2 is 7, but you're at 7, right? And you have to add one more. So the next number is 1, 0, because you add a digit and you go to 0. And then 1 plus 2 plus 7 is you have 7, and then you have to add 3, so 7, 1, 0, 1, 1, 1, 2. Then you have 1 plus 4 plus 3. 7 plus 1 is 1, 0. Okay, actually, for the sake of time, I'll just show these answers. You can rewind the video if you are confused. Okay, if your answers match up with these, then that's great. Okay. Now we'll go over hexadecimal numbers. So hexadecimal numbers are base 16. Okay. And you're thinking, right? If you have base 16, that means there's 16 like one-digit numbers essentially. So instead of the numbers 10, 11, 12, 13, 14, and 15, because they're two-digit numbers, hexadecimal uses letters to represent them. So hexadecimal has digits 0 through 9 and A through F. All right. So I think hexadecimal numbers will actually be the topic of our next video. So this was just a preview of hexadecimal numbers. For this video, we're just going to keep it at octal numbers. So you have separate videos for octal and hexadecimal numbers, and you don't have to go to the middle of a video to find hexadecimal numbers. So yeah, you got a little preview of what is coming next, but that is all for today. And thanks for watching. Bye. Okay, bye for real.